Hey everyone, and welcome to another video in the Microsoft 70761 preparation / refresher series. My name is Elric, and in today's video we're going to discuss aggregate functions along with halving. We're going to go pretty in depth into group by and ranking functions, but more importantly we're going to be covering windowed or window functions. So before we begin, a couple things. In the description you will find a download for this file, 004 tutorial scripts, so you can follow along or experiment. And you also find 004 create scripts, which I have made some modifications to. I did add another example table and filled it with, about 12 different records, so I could better explain these aggregates and how, what's going on. So also in the description you'll find minute markers. I will try to capture the time at which I am discussing these subjects, so you can skip through. I do recommend watching this fully at least once, just so, in case there's something that I mentioned that you may or may not have known. But, they're here for your convenience because these videos are kind of long. Lastly, you'll find in the description a spot for additional comments, so if you have any else to add to this specific conversation, please do comment so I can add it. And yeah, so just to get out of the way, since you can skip through, like, comment, subscribe, and here we go. First we're going to cover aggregate functions. I have just pulling the data up here, and all of the aggregates I'm going to talk about, because some of the aggregate functions are analytical or analytic functions, and since this exam is really querying with T-SQL, like do you know how to query with transact SQL, they're not going to go over cumulative, distribution, lag and lead, because that's a different side of of SQL. So I do not think they're going to go over standard deviation and variance. However, just in case they try to ask you the difference between the two, because this is still considered an aggregate function and not inside the analytic function side, I'm going to cover them, at least the difference between the two. So these aggregates are a no count aggregate, so we don't have, no group by aggregate, so we do not have the group by down here. And this first data set is just the raw data. And I'm using a tool by DevArt called SQL Complete, which I highly recommend picking up. That'll allow me to highlight these things and give me some information so I can better describe to you what's going on. So just to go over the code up here real quick, I do have count, count distinct, count big, and count big distinct. Now the only real difference between count and count big is that count returns an integer, and you can see that says returns int on that first line, and the count big returns a big int. And I do not know the floor, ceiling, or min-max for count, or for an integer, but I believe big int is like -9 septillion to +9 septillion. So just kind of think about, in a large volume environment where your counts may get that high, there is functionality that you can use, and these will start to error out at that level. And then next two aggregates, minimum and maximum, or min and max, essentially just provide the count and count distinct. So when I highlight these rows down here, I get a count and a distinct. And what is this? This is on the date, so I'll highlight these rows. Count 12, distinct 10. So that's basically all the aggregates are doing, are saying, hey, there's 12 records coming back, but only 10, there are 10 unique values coming back. You can see that the code down here matches my little tool up here. So now going into min and max, I'm operating off of the quantity now, so I can highlight these rows. You see the maximum is 52 and the minimum is 6. And min and max 6 and 52, and this is just the lower end, the minimum, the floor, and the maximum, the ceiling, that high end of the values that you return. And it can work with dates, it can work with integers, etc. So I also have average in here, and I have 3 different averages for a very particular reason. They're all working off of quantity, and as I highlight all of these items, you see that it says average 24.5. And this first average right here only says 24, and then we get 24.5 and 24.50000. Now this is because I am sending in a big in, or a non-decimal numeric, into the average, and it's returning a non-decimal numeric back. And it's not even rounding, it's just truncating, it's cutting off that decimal. And as we move further along, you'll be able to see what I mean by that. So I am doing 2 different types of conversions right here. And I'll cover cast in another video with null handling and try cast and try catch, or try cast and try convert. I am explicitly casting this quantity as a float, and I'm getting a neatly trimmed decimal back. And this is an implicit conversion where I am multiplying something by 1.0 just to get that decimal back. So as I do this data, which could be, 24.000 and 42.000, is being sent to the average function, where it is then averaged and sent back. So that's where the precision differs between these 2 values. Is when you're actually casting it, when you're explicitly casting it as a specific value, you're going to get that neatly formed value back. However, when you're just doing an implicit conversion, it's going to stop wherever its default is, and in this case it's 6 to the right of the decimal. So it's really important, just like we were talking about implicit and explicit joins, implicit and explicit anything is a very important subject to know, and know the difference between the 2. So this is, like I said, this is the explicit conversion and this is the implicit conversion. Sum is basically just adding all of those values together. You see 294 and 294 match up. When we look at standard deviation and variance, I kind of want to go back to sum and average. Now, we may understand that the average is the sum of all values divided by the number of rows returned. So that's how we get the average. Now with variance, I should be doing this. With variance and deviation, they use the number of rows, or the number of records, samples in that data set in their equation also. So there's a difference between standard deviation and standard deviation population. And that's why I have sample and population as suffixes on my variable names, because these 2 aggregates, when they are not followed by the P, which abbreviated for population, it is assuming that you're not giving these functions the complete data set. It's assuming you're giving them a sample of. So it's considered a non-biased function, because it takes the number of rows and it subtracts 1 from that record, from that number. So for example, we have count 12. If we were to translate that into average, average makes a little bit more sense. Instead of adding all of these up, dividing by 12 to get 24.5, it would add or count the number of records and then subtract 1 to get 11, and then divide it, which would throw off our average. And you can see down here that the deviance does change quite a bit in terms of deviation, and the variance changes even more. So we have a bigger range of change. The population side of things is a biased set, meaning it's going to use the entire count in its equation, because it's assuming that you're giving it all the data. So when you see, or if you are asked about the difference between the 2, understand that deviation, standard deviation and variance followed by the population abbreviation represents that you're giving it all the data. And the ones without represent a sample, a training set, a partial data set from that full. So just wanted to talk about that just in case, because these are listed under aggregates, while league, lag, cumulative distribution, and others are not. They're listed under analytic functions. So now I'm going to go into aggregates with group by, because there's a lot of different hints with group by, and I'm going to run these two data sets again. The top data set is just the ungrouped, just the raw data basically, and the bottom data set is getting purchaser with a group by purchaser, and I'm just doing count big, average, sum. So in here, because of my order by, I got it ordered by what I'm grouping. So I can highlight this data. You know, we'll see the count matches up. We'll see the average. Once again, it's truncated. The min and max, just for this sample data set that doesn't do not have that down there. And if I highlight Hugo's, you see 22.8. So the average is just 22, knowing that it is definitely truncating it. Now with grouping, you can group by more than you select, but you cannot select more than you group by. And what I mean is that if you have any sort of aggregates and you want to select non-aggregate columns, they must appear in the group by statement. So if I run this, I'll get a fail because product is not in the group by statement. I have it commented out. This would be that full item, or both of them are. And I'm going to run this and the one below it because I'm grouping by more than what I am calling. So you can see it's the same data set, and we're going to use this example data set quite a bit from now on. But all it's doing is it's removing that column, just like a normal select statement would. So it's really important to know that you can, in fact, select less than what you group by. However, whatever non-aggregated field that you are selecting must appear in the group by statement. Now I don't want to, and here's the thing, I don't want to say, we're gonna kind of get around this rule later on for window functions, where we're gonna use aggregates and not require to use the group by. So in case you're watching just for the group by, know that in the window functions, we can get around not using the group by. So with having, or the hint having, is basically a where clause for aggregation. So if I take this sample data set that you're going to see a lot of, and I just look at the averages, 22, 23, 25, 28. Down here I have this hint average, the same average that we're doing, greater than 23. And what that will do is it's kind of giving us that where clause. Instead of, pushing this forward into a subquery and then selecting from the subquery where greater than, 23, whatever we call it, ag average. So having is kind of that that where clause for your aggregation. And because most educators use the student teacher or classroom example, you just think of it as, well, I want a student ID, I'm going to average out their grades, and I want to find all of the students' average grades having an average greater than passing, right? Which is not 23. So a quick demo, just because I want to try to include a demo in all of these videos. Not much to demo with these aggregates, except I can use having for a duplication demo. So if I just run this internal inner join query, we can see that I have two dates that have more than one count. That's how above our aggregation count distinct, we get 10 back when there are 12 records. So a really common answer to this problem is, get your aggregate on the inside and then join, basically a self join that same table with the aggregation on the duplicated column to get the records that are duplicated. So just like in the previous video when I did a NTILE sum aggregation, I'm going to run these, and I'll make sure I have my execution plan. I get the same data back, and this is actually using an exists statement where I am passing the date down with a count, no group by, and just saying in here I'm having a count greater than 1. So it's basically every record up here is being passed down. Here's the where clause where the top equals the bottom. This is the bottom, and it's saying, you know, hey, I'm going to pass this record down, and if it comes back as a count greater than 1, then I'm going to include it in my list. Now the crazy part between these two plans is that the exists is significantly faster than that self join. So in terms of optimization, just in terms of being a great developer, it's really important to continue to experiment with different ways to do something, because you never know what you run into. And essentially, the difference between the two is that this exist statement is going into that cursor-based loop functionality, while the inner join is still performing the merge join. So most of the time comes from that merge join. The sorting, yeah, but you know, I suppose it's the cost of a merge join versus the nested loop is where it's at. This additional feature is, you know, whatever. We can get around the sorting if necessary. So a part of the group by structure, and I will come back and comment on this comment in a little bit. One of the hints is ROLLUP. So if I have, and I'll just run them both, that data set that I said we were going to be seeing a lot of, right here. Come on, scroll for me. There we go. And here's my ROLLUP statement. So this is the standard count big average sum, group by, purchaser, and product. Now the ROLLUP does contain, oh, not this again. The ROLLUP does contain that sample data set, or the same data set. However, it adds 3 additional rows. Now what's going on is when that ROLLUP is happening, first it's doing the, let's get it all in frame. First it's doing the group by for both of these items, just like this top query. That's how we get that second data set in here. But next, what the ROLLUP feature is doing is that then it's removing the farthest right column from the group by and replacing it with a null. So because these two line up, this is converted to a null, and then it executes the same aggregation on purchaser, because that's the last remaining column, but it replaces product with a null. And that's how you can see that we have the null, the 2 nulls, but it's still grouping by purchaser. And we can just look at the quick math. I mean, the average kind of works out. It's probably a decimal, because between 25 and 28 would be a little higher. But the sum works too. And then finally, the ROLLUP is taking that last column out, replacing it with a null, and then running the aggregation without anything. And that's how we get 2 nulls down here. And it's the grand total. So the ROLLUP feature kind of cycles through the different group by, but it's really in a step type method, and that's what they call it, ROLLUP. So here's the very bottom, and then it rolls up, takes one off, aggregates, takes the next one off, aggregates, and if that's the last column that it takes off, then it stops. And this is a ROLLUP, and I'm going to run all 3 of these, where I just switched the order of the columns, which will produce different results. Now we do get that standard data set that we are going to see a lot of in both the first and the second rollup, but just looking at it from a high level, there we have 3 nulls here and only 1 here, and we have the 3 nulls on this side. So once again, that's because during that rollup, so this is a purchaser, that's the second one, this will be the third one. It is taking the purchaser off this time. So that's where we have the 2 nulls in the purchaser, running the product only, which is where we have this product, and then taking them both off. So we do get, it's like how different is, well, very much different. We do get 2 different slices in these 2 different queries just by changing the order of the rollup. So once again, the rollup function is grouping by both columns and then subtracting the farthest right one and just grouping by that one. And it continues to do that until there are none left. It executes the aggregation like there was no group by, and that is the end of rollup. And to comment on that comment above, essentially this is what it's doing if we were to write rollup out in code. Group by both, subtract 1, replace it with a null, group by again, put null in both, and get your grand total. Cube is a little different. We can get the same result set from rollup, but in most cases we can't. So I'm just going to take the standard product first and purchaser rollup, and I'm going to execute it along with cube. Now inside of this rollup feature, we still see that same data set that we're going to come in contact with. And in the cube, we also see that data set. In the rollup, we have that null, let's say group by product, and we have the group by products down here also. We have the grand total, and we have the grand total here in the cube. But we have the additional 2 rows, or 2 records, that we got by changing the order of the rollup. That's because what the cube does is the cube is essentially a cross apply or a Cartesian of group by statements. So it's going to group by all of the columns here and every combination of columns to get that information back. So it'll do product and purchaser, which are these. It'll do product only, which are these. It will do purchaser only, which are these. And then it'll do none of them, which is the grand total. So rollup and cube do follow specific patterns. Rollup being that it steps through it, executes the full string, takes one off, next string takes one off, without group by. And cube does every single combination that it can have. And just like normal grouping or normal group by, we can roll up and we can cube by more than what we call in the select statement. It just gets a little confusing to try and figure out where the columns come from. And that's where grouping and grouping ID come into play. They're kind of hard to work with, but they are here. So I'm going to be executing the cube again to try and explain what grouping and grouping ID does. Now for me, grouping is a really hard concept to explain because it works in the opposite of what I would assume it would work. The grouping says, given using a cube or a rollup, it's going to essentially just give back a 1 if the row is added by either of those functions. It says it's a 0 when it's not. But the staggering is kind of like, well, I know this is part of the rollup function, but it's only part of one side of the, or part of the cube function, but it's only part of one side of the cube function. This I know is part of the cube function, but it's part of the other side. So it's like really we have to add a grouping, because if you imagine that it was just these, it wouldn't make much sense if it was just one column with one grouping. But adding both grouping by everything that we're actually grouping by, we can develop, or we can see this pattern. And this is why I say that it almost feels like it's in reverse. Every time I see a 0 if I look at both of these columns, when I see a 0, I kind of know that it is grouping by both of those columns. So having a 0 in purchaser and product gives me that really common data set that we see. Having a 1 in purchaser and a 0 in product, and like I said, it feels like it works in reverse, we're actually grouping by product. So we are grouping by product. And that pattern is applied in the opposite, where we are grouping by purchaser while the product ID is 1, and we're not grouping by either, both of them are 1. So that's why I say is like grouping, it's hard to just say, hey, when you see 1 it's added because of the cube, when, for me, anything that's not this seems to be added because of the cube. So that kind of opposite pattern allows allows an easier explanation. Given two groups, two items in the grouping clause, the 0 is what is being grouped at that moment. Both of them are being grouped by, only product is being grouped by, only purchaser is being grouped by, and neither are being grouped by. And grouping ID kind of just adds a little more confusion to it, but until you can predict the order in cube and rollup functionality, like predicting in rollup is pretty easy because it's just taking that farthest rightmost item, so you can tell programmatically what it is. But grouping ID is the count, basically a level. When you think of recursive CTEs. So this is the base full level, and because this is a cube, so we're going for product first, and then we're going for purchaser second, and if we had a third column in here, that's when it gets out of control, and I think you come up with 9. Let's just add one in there just to see, and then I'll, oh yeah. Gotta get the dates in here. Seven. So we added one column but got 4 additional because that's that Cartesian. Grouping. But just looking at the simpler form, this is a specific group and this is a specific group, and the minimum grouping ID is always the full all group by clause. Every single item is in that group by clause, and the maximum value is always that grand total where nothing is being grouped. So just two different helpers that we can use in trying to identify what we're actually looking at when using cube and rollup. Grouping sets is actually pretty fun to use. It's a very interesting concept. Let's take these off, and I'll just focus on these two. So when we worked with the group by earlier, I said that you have to group by every non-aggregate column in these cases. I just want to say, like, without window function cases. And in here, we are grouping by them separately. So grouping sets allows us to choose how we group by. So I have you know, I don't have both of these grouped together. I have just the purchaser and just the product aggregation. However, I could almost create a roll-up. We just don't get that grand total. So I can run this and, well, almost create a cube. We just don't get that grand total. So I do have that common data set because I did say, hey, group by both of these. And then I group by them individually to get different data sets. Now you must have both of the columns. Actually, I'll do it this way. You must have both of the columns in your grouping sets statement. It's just like a normal group by clause. You must at least call both of them, but you don't have to call them both together. So now, ranking functions. Now ranking functions, pretty easy to explain because you can't add a window on a ranking function. We can add order by, this is the case. Row number, pretty standard. It's going to increment based on the order by you've supplied. And even if there is a duplicate, it's just going to pick one based on like the order of the table. And you will see no duplicate values. Ranking, on the other hand, when you hit those duplicate values, it's almost like with ties from the select video, is that it will give you the same number back and then skip however many places that it used. So you do not see a 4 in rank, and you do not see a 10 in rank because it went 9, 9, 11, you know, instead of 9, 9, 10. And that's where dense rank and rank are different, is dense rank still does duplicate. Because we're ordering by date and we're getting a tied date, it still gives us the same number, but then it just continues on with the sequence. And NTILE just tries to split the rows in as many groups as you provide it. So if I say split it into 4 and run it again, it'll try to give me 4 equal groups. And because we have 12 records, it does give me 4 groups of 3. Now with partition, you can reset those ranking counts. So I'm partitioning by, let's see, we will do this first. We'll cover the first 2. Let me run this again. So these first 2 items, I'm partitioning by purchaser. So 1, 2, 3, 4, 5, 6, and the count resets 1, 2, 3, 4, 5, 6. And NTILE tries to, once again, convert into 4 equal groups, but because we have 6, we don't get the full equal groups. However, we are always getting 1 through 4. It's going to try its hardest to give us that information until we have less rows than groups that we're trying to create. And for rank and dense rank, we can reset those ranks, but in this case we don't have any ties based on the dates sold, based on what we are ordering by. So that duplication of numbers and, you know, the skipping of the sequence does not exist now that we added partition. So it's just something to think about when you're ranking things, and especially given the questions that they ask, and kind of they're almost word problems. They say, based on this, this, and this, what are the expected outcome, or what is the expected outcome? Now over, and so this is the over function as partition and order by. Now over also has window functionality, range and rows. However, you cannot use them. I repeat, you cannot use them with ranking functions. If we tried to add any sort of window functionality here, it would not work. So I'm going to go over the first window functionality with rows. So rows is pretty easy. And I'm gonna run these all, and I'm gonna drag this over here. So we only have so many words that we can use. Let's see. Sweet. We only have so many hints we can use, and it's really, you think of it as the start and the finish. So I'm going to start at my current row, and I want everything before me. Or I'm going to start, let's see, everything before me and the current row that I'm at. So when you think of these functions, always think of the place that you're in, because everything here I'm ordering by the primary key just to make it easier to understand. So this is the place you are at. And if you understand cursors, you'll understand this very well. So let's just jump into the different windows. So if I start at row 3, I'll highlight this. I have a quantity of 42. And this column says the current row and the unbounded following. So that means, because we have a partition by, which is the purchaser, that means it's this row plus all of the following rows. So that would be 105, and that's where we get that number from. And if we move to the next one, it's this row plus all of the following rows in that partition, 63, 63. Unbounded preceding in current row, and it's really important to say you cannot do current row and unbounded preceding, because this has to be lower than this. It's drilled, like, yeah. When you're using between, I know in normal code you can say between tomorrow and today and get nothing back. However, when you're using between in this window function, it always, the left always has to be less than the right. So with unbounded preceding, using that same example, we start at 3. Preceding is before. So unbounded preceding in current row. So we take this, and I'll just move this over. So we take this record and everything before it. Take this record, everything before it, since we are summing quantity, and we get 94. Same thing, because we also have a partition. If I go down here and then take this whole record, it's 157, 157. When we do not add a partition, it doesn't reset anywhere. So we wind up getting the whole entire data set at the very last record in our order. Oh, I am summing the wrong thing. So 294 and 294. We can start anywhere, 157, 157, and you will see that pattern take place. So we can have both a partitioned and a non-partitioned overstatement in the same clause. When we do, it's valid, we can say between current row, and we don't get anything back. And I'll explain this current row to current row, why you would want to do that with range. And then finally, we can actually give records, like we can give specific positions, 2 before this current row and 3 after this current row. And because I do have a partition, 2 before, 3 after, this whole partition, oh, there we go. This whole partition would make up that middle record, 157. So the 2 before is not including the current row. So I take the current row, 2 before, the current row, and 3 after, but because of this partition, it stopped. So we get 137 in this little area. So that's what it's kind of saying about window functions, is that this window basically moves and it gets smaller once you hit that partition, but without that partition, you can almost take that chunk and just kind of, this highlighted area, and just everywhere you move it, you're going to get that value come out. Instead of using rows, we can use range. And this is where, no, I have current row to current row. This is a little more difficult to explain. I moved over to date sold because we have duplicated data. And range is kind of like with ties. So when I say between current row and following, what I'm saying is that when I get to, and I'm ordering by date sold, it's really important that we order by this, because we could have some crazy results if we didn't. If I didn't order by date sold, and it would it would cause some crazy stuff to happen. The numbers wouldn't make as much sense when trying to explain this range. So this range right now is current row to unbounded following, so everything before this date. If we look at it, we say everything including and before this date, and if I go get my quantity and I just highlight these items, we don't get that same count like we did with the rows, because no longer is it looking at the row, it's actually looking at the value. So, following this date, my bad. So I'm getting 245 in two places because this is tied. So even when I go to the next row and get my window, it's still, it's not just looking at the row, because this would be 233, it's looking at the value. So everything after 1013, and that's how we get the same number in two locations. So that works for the unbounded preceding also and current row, where either of these are the current row. And I'll bring this over here, unbounded preceding and current row. And both of these rows have that same 86 because they are both 1013, just like down here, they are both 18. So both of these in different locations have the same data, same number. It's not cumulative like it is in rows. But the cool part, which is pretty interesting, between current row and current row in the rows version just mimicked the same number that was provided in the quantity. However, with range, current row and current row does mimic it until it gets a tie. And then what happens is you just sum the ties to get that specific number. Same down here with 18. So these window functions, I mean, you should spend a lot of time experimenting with these just to find the ins and outs of them. They're very strict. There's not a lot that you can't do. I mean, no partition, unbounded preceding, and even up here, I did give a little hint with the things that you can use. So range doesn't give you that following and preceding option, so you cannot give it 2 following, 3 preceding, or things like that. So definitely experiment with these rows. And I believe that is it for the aggregates and the ranking functions. Thank you very much for tuning in and working on the next video, and I will upload it as soon as possible. Once again, like, comment, subscribe, and I wish you luck. Only so many videos to go. You guys have a great one.